So let me introduce you, Samir Santa Maria of Albus. Yeah. Where is the stroke and the stress and the second syllable? Albus or Albus?
Albus.
Albus, okay. So who's going to tell us about mixed up or oh, that's the
Well, so what I'm going to talk about is A plus B conifold transition with atoms. This will lead to mixed atoms, but I will not talk about mixed atoms. And by the way, in the website, my name was there was a doctor before my name. I'm not a doctor. Actually, I am a first year graduate student here at UM. So, yeah. So let's talk about transitions. Well, usually when we have a singular variety, we do either a resolution or we do a smoothing. Here, that singular is a normal projective. It's a threefold with singularities. Say V1, decay. Five, the projective, small, present, resolution, and R is a projective, small. So what we want to know is how the resolution and the smoothing compare. This is what conifold transitions are about. I'm not going to talk a lot about conifold transition, but the quantum version of conifold transition that comes from a paper of Iritani. So basically, left. You will see I with a nautical variable corresponding to C. CI, where each CI is this. Very interested in the exceptional quantum locus. That is when we get all these symbols and they should be equal to 1. In this locus, we will have the following. We will have that quantum connection. Of the resolution will be now look alla somma and I EQCI over 1 minus QCI where the now prime is regular along delta and Ni are endomorphisms of the cohomology of the resolution and is important. Each of them open. We are going to define B, the intersection of the kernels of each and I, W, B intersected with the summation of the images of an eye. So, what is proof by Iritani and Xiao is the following: is that the having a conifold transition the now prime, that is the same that we have there, restricted to delta induces a flat connection on B over W. Moreover, we will have that the quantum homology of smoothing will be isomorphic to B over W with the quantum product equal to when this is equal to 1. So this is a great result, but we want to add atoms to this.
What is QX?
This should be one of the Q's that I don't know. Okay. Should be just Q. Yeah, it's one of the numerical variables in those. Now, we want to introduce following version. It's a topological defect. The topological defect is defined in a lot of ways. Perhaps the most useful one is the dimension of the kernel of H3 U to H4 sigma, where U is heads without the singular points, and sigma are the singular points.
Sorry, may you just clarify one thing? This is the big or small quantum homology?
It's the small quantum.
The small, right? Yeah, okay.
So what we plan to do with the atoms is to record all the information that we have in the conifold transition and add the defect. So to introduce conifold transition in atoms. Each node contributes a one-dimensional data object q minus 1. So for k nodes, we will have this to the k. We define the excess a model contribution to it.
So you are saying that the singularities are always nodes?
Yeah, the singularities are
always nodes. So then the plane, the idea is that each node will do a Hodge twist. A take twist.
Yeah, find the a model contribution of the second homology of the resolution quotient by the second homology of the smoothing. And we define the B model contribution, the B model contribution at the vanishing. So we will have a short stack sequence that will be moderating later. Will be the following. This will be the local A plus B stack sequence, but we will see that later.
So maybe you just ask one thing else. The idea of this A-axis is to mimic this VMW on
the idea.
Because what exactly you mean by A-axis? So it's just to take this homology, it's just this, right?
I mean, it will be for later when I introduce the A plus B theory. So, calculation. the mixed atom. So let's say that we have a resolution. And the idea of mixed atoms that we have is the following. We have B over W that we believe that it defines a birational invariant. We have this exact sequence. And we have the defect. The idea is that with this data we can define the mixed atoms. But I will have in this document. Well, now I'm going to define what we mean with A plus B.
What's the role of this defect? What's the role of this defect? And why it should participate in the picture? Why? What's the role of it?
Yeah, so the defect appears when we talk about topology of Banach quartets. Well, the whole idea, the main idea of this is to answer to rationality questions. So this defect, how to do it? That like there are the definitions to this, like the rank of the dimension of H4 minus the dimension of H2, or something like that. Like this helps answers rationality questions, so that's why we want it. Yeah. So, A and B model. What I refer to A and B model is the following. So that AX Gromov Witten theorem. Of X. This is governed by the Duobrium connection. And we have the B model, that is the variation of Hodge structures. And this is governed by the Gauss-Manning connection. So the idea of A plus B theory is to use both of these data at the same time and group them in some way. The easiest way we can see this is that is sigma equal B1, Bk, be the singular points of X, Ti, the exceptional curves of the small resolution. SI, like this here, be the vanishing spheres. Of the smoothing. We have two relations. We have AI times these are coefficients. These as well. BI. So here basically we are going to encapsulate this data into matrices. We let the A be a relation matrix. The curves. And B for the spheres. A will be NK times mu. And B NK times from. And we have the following relation that mu plus from equal to K. Now for a conifold transition, we x equal this smooth as far it is to equal the resolution. We have the following theorem by the being on one under a projective conifold transition of smooth projective variable ripple. There is an exact sequence of way to Orchard structure. Follow. This B is the matrix that I defined. This CA. For our purposes, we will rewrite this as just for it to coincide with what we have been saying. Now, I completed some. Suppose that k is equal 3. We have C1, C2, C3 equals 0. Then we will have A equal 1, 1, 1. Then it goes from Q, 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 and it's given by A, B, S1, S2, S3, S1. The kernel of 18 have dimension 2, and base is so base is 1 minus 1, 0, 0, 1 minus 1, and thus we choose B in 1 minus 1, 0, 0, 1 minus 1. So the exact sequence becomes 0, Q minus 1 square. Here we have the dimension of the stairs of the A model is 2, and the dimension of the B model is 1. Now, following that the A model corresponds to the two-order connection and the B model corresponds to the Gauss-Manning connection, we want to have some way to glue them. And this is what our next theorem says. Via the exact sequence, the trivial logarithmic connection on C plus C equal K to CK. Induces simultaneously the logarithmic Gauss-Manning connection on B. Yeah. And the Dubrovin connection H2 y over H2 x. So what this is saying is that the excess of A plus the excess of B is locally trivial. Now we're going from the last theorem before introducing atoms to this. Now with that. Projective conifold transition of three-dimensional Calabi Gauss. Then AX, that's superior. Of this A1. BY is a subtheorem of BX. AY can be reconstructed on a refined A model of a circle body when we delete all the vanishing spheres on it. Or similar BS can be reconstructed but this time instead of eliminating the vanishing sphere, we will eliminate the exceptional colors. So now we are going to the settings.
Just to be sure, X is Calabi-Yau also, right?
Yeah.
And when you say it's a subtheory, exactly what do you mean?
It's not really a formal definition, but we define AX to be the Gromov Witten theory of components. It's all the data that we can get from the Gromov Witten theory. So it's like, yeah, it's not anything formal, it's just a way to say that it depends on me.
And you don't have to pass for X bar to prove.
No, because I mean, X bar is there, but it's not important for things. So we have three objects that we want to take care of. We have V over W, that is a common piece. we have the shortcut sequence. And we have the defect. This is basically what our information of patterns will be for the A plus B conifold transition. Definition. The A plus B conifold transition. Atom transition. Associated to that will be all of that. We may as well use the wall to kernel instead of the dimension, but I prefer to see the dimension. So we have the following proposition. The following example.
You most likely also want to take EW with some quantum product.
What?
E mod WU, maybe you want to pick with some quantum product. That one coming from Equivariant.
Yeah. Let's assume that the dimension would be equal to 1, dimension of A equal to 3. We have the following. The effect will be three. In the case that the dimension of B is equal to 2, and dimension of A is equal to 2, we have all the we have that the effect is equal to 2. So notice that in this case, both conifold transitions have the same number of singularities, but they give different information. In this case, we have that the defect is 2, but in this case, we have that the defect is 3.
Can you repeat, sir? What was it?
The conifold, in both cases, the conifold transition have the same number of nodes, but the defects are different. So this, they are differentiating as well. Some results. Vision. Let's go on vision. With the same number. So if one, but yeah, if the dimension of a one different to the dimension with them, then tau one, tau two can be as small as filter touch object. It was something that was implied. Example. Or proposition. The effect is independent of the choice of small discrepant resolution. Particularly we have two of them. We have the local. They equals B atom of down plus are identified how to change basis of the local nodelet. So, okay. It's isomorphic to you understand K y prime up to n prime the two local the two nodal lattice. That's like the flow.
Can you recall me what is another lat? What is another lat?
When it's a nodal lattice in A, so this is the final thing I will say for logic. Dimensional AY equal to dimension of AY prime will be the consequence of the effect of Y equal to effect of Y. That's all I wanted to say to him.